Hello and good day, geometry. We are moving on in our unit on similarity and proportions to talk about proportions. Okay, we spent CO33 kind of reviewing the ratios. We talked about how our ratio compares a part to a part and how we can use ratios to find like angle measures in a triangle or side lengths if we know the perimeter. Today we're going to kind of review how to set up a proportion and then how to solve a proportion. First of all, definition. What is a proportion? The definition of a proportion. Damien.
Proportion of something, like a quarter of something, like a proportion.
Okay, yeah.
Part.
Yeah. Kylie.
You compare the part to a part.
That's what a ratio does. A proportion is a little bit different. A ratio is a proportion. It's kind of like a subset of what a proportion is. Ellen, bring it in here? No? No, that's what a fraction is. Part to a whole. A proportion.
I go to the bathroom.
Yeah. A proportion is two equivalent fractions. That's what you're going to say, right? Two equivalent fractions, which you can see here. Right? Whenever you set up a proportion, it's going to be a fraction set to another fraction. We're basically looking for what value for n makes 2/9 equal to 5 over n. Okay, and sometimes you can use scale factor to help you. Like sometimes in this case, 13 goes into 78 evenly. Catherine, you have a question?
Are we still doing that thing where you can only leave the classroom 7 times?
Yes.
Well, you didn't just mark the infinite
Yes.
down.
Yes. How many times does 13 go into 78? More than 3.
4.
More than 4.
5.
6. Okay. So the scale factor between 78 and 13 is 6. Right? Going from 13 up to 78, we're multiplying by 6. You go from 78 back to 13, we're dividing by 6. Which means that to solve for n, we apply that same scale factor to our numerators, and n is going to equal 6. Okay? So that's kind of how you grew up, learning about equivalent fractions and proportions. Everything always worked out very easily. That's not always going to be the case. Here we have 2/9 equals 5 over n. What is the fail-proof go-to method? I need you to raise your hand, please. What is the fail-proof go-to method for solving a proportion that you've used before? We did it last year. We're going to use it again this year once we get to our next unit. Kylie. Cross multiplication or cross products. Basically, in any proportion, you are guaranteed, right? What makes these fractions equal, you are guaranteed that the product of 9 and 5 is going to equal the product of 2 times n. Okay? Which essentially means you multiply that 9 and 5 together, and then to solve this, you n by itself, you divide by 2, right? And that gives you a value of 22.5 for n. Okay? Cross products is also one of the ways that we can determine whether something is proportional. If you were to multiply 6 by 78 and 13 by 36, you get the same product. Right? It's a way to determine if two things are proportional, or in this case, solve for a proportion. Where we're going this year, this is like pre-algebra proportions here. Okay, where we're going this year, and we did a little bit last year too, but there's extra stuff going on. Okay? Yes, this is it. Yeah, 22.5 equals n. Right? Kind of, you may also know it, girls, as the rule of 3, where if you have 3 of the 4 parts of a proportion, right, you multiply the 2 that are diagonal and divide by the 3rd. Catherine, that's basically the gist of how cross products works, right? But over here, where you got more stuff, and we're multiplying that 4 times n plus 9. How do we do that? What do we need to make sure that we include in our equation when we write this out? Aiden?
You distribute the 4 into the n and the 9.
Right. We are going to be making sure that we add parentheses here, because we're not just multiplying the 4 by n. We're not just multiplying the 4 by 9. We're multiplying 4 by the sum of n and 9. Which, as Aiden said, we are going to have to distribute in, okay? But it's that understanding, it's that notation. When we do it here, right, it's not just 2 times 5n, not just 2 times -3. We are going to need to distribute that 2 into the 5n minus 3. Yes.
You get 4n plus 45.
Close.
36. 4 times 9. Oh.
4 times 9 is 36. Right?
My bad.
Oh, that's not right.
So 4n plus 36 equals 10n minus 6. And I have variables on both sides to solve here. Where do we go from here? Where do we go from here? Damien.
You do the railroads, and then you minus 4n so that it cancels out, and then you put it to the other side, and you minus 4n to 10n, and you get 6n, and then you plus 6 on the other side, or add 6.
Can I push a button?
Yeah.
Essentially, yes. Okay. We want to get n by itself. Damien mentioned a whole bunch of things, including subtract n from both sides to move it over to the right side. Could you move your 10 n's over to the left instead? Yes, you could, right? But then you're dealing with a negative, and maybe you don't. Maybe you're a positive person. You don't want that. It doesn't really matter as long as you move all your n's to the same side, right? That's going to leave you with a two-step equation. And so then you're going to add 6 to both sides, giving you 42 equals 6n, divide by 6, and eventually you get n to equal 7. Where does he have up yours?
Oh, man, asking. Why?
Yeah, I think it was better.
This isn't working out.
He's
No,
giving
please
me a
don't send me that.
handshake because I
This
got
isn't
the
working
button.
out.
It's because I got the button.
Put water on myself.
Please, you're not turning around. You're facing the front.
Feet in the front.
Questions on your quick review on proportions, cross products, some equation solving, anything not driving, not clicking, not remembering. Damien.
Do we have to plug it in?
It depends. If you're asked to solve for the variable, you would not. If you're asked to solve for a side length, and the side length was labeled n plus 9, if you look a little bit down the page, I think it's on this page, like a side length is labeled with an expression. So then you have to solve for n. N is 7. If you're asked to solve for the side length, you would plug it back in, and this side length would be 16. So it depends on the question that's being asked. So pay close attention to that. Sometimes you will, sometimes you won't. Okay? All right. Well, let's get to looking at solving proportions. We already defined a proportion up above. A proportion is 2 equivalent fractions. Two equivalent fractions. And the key to setting up a proportion involving shapes is to use corresponding sides. Okay? The key to setting up a proportion with shapes is to use corresponding sides. Yes?
Did I need that for any particular reason?
She did not. She did not.
Brilliant.
This one. Nope, this one. There you go. That one.
So you're wasting my time.
Yep. Yes, that is correct.
Brilliant. It's one of the red ones at the top.
Or
Did you see the words she said?
there's so many buttons, I don't know which one
Pop the
button.
balloon.
There we go.
Are you gonna actually apologize?
No.
No, that doesn't count. Words.
Apologize to her.
Hey, hold on, come back.
Brilliant.
Ella,
Chase
go
after
for it.
her.
Go
Chase
for
after
it.
her.
Anyway, when
Joey.
you're setting up writing proportions with shapes, your key is corresponding sides. Okay, so we've got two shapes here. They are similar. They are proportional. Give me one proportion that you could set up with the given values. Yes, Bryn.
8/4 equals 10 over n.
Okay, And we'll use x just because that's the variable that's even what's there. It wouldn't really make a difference, but just people watching. So one possible proportion here is 8 over 4 equals 10 over x. Okay? Notice where the 8 and the 4 came from and where the 10 and the x came from, right? The 8 and the 4 come from the same shape, which is okay. Because the order that Bryn put them in, kind of that longer side over the shorter side, she did the same thing with the second shape. She put the longer side as her numerator and her shorter side as the denominator. Okay, so that works. It's okay for a proportion to contain two sides in the same shape, as long as you use those corresponding parts of those same positions in your second portion. Okay, Damien, what's second one?
X equals 5.
Thank you. Yes. What's another proportion that we can set up here?
Oh, wait.
Jack.
2 over 1 equals 10 over x.
Let's use the values that we have here. We could simplify 8 over 4. That might be a method to solve it. But just going from this to the proportion, we don't have to go in this specific order. There are other ways that we could do it. Do you see another way that we could?
Yeah. 4 over 8 over x over 10.
Okay. You could stay within the same shape like we did in the first one. That 4 and the 8 are together in the same fraction. But this time, we're going from the shorter to the longer. As long as you do the same thing in your second shape, go from shorter to longer, you're going to be okay. Damien already solved this for us at x is 5. You can see x is 5 here too. 4/8 is equal to 5/10. So it really comes down to going in that same order for both proportions. Yeah, right.
Isn't there more?
Go for it. What else you got?
4 over x equals 8 over 10.
Okay. 4 over x equals 8 over 10. Here, we're kind of going from one shape to the next within our proportion, right? 4 and x are from different shapes, but they're corresponding sides. And as long as you keep that order, first shape, short side, second shape, short side, and then 8 over 10, first shape, long side, second shape, long side, you're going to be okay. Okay? And then, of course, you also flip that around. You could do x over 4 equals 10 over 8. That would work also. Okay? There's a lot of options here. You don't have to do them all. And if you plug in 5 for each of these, 8 fourths equals 10 fifths, check. 4 eighths equals 5 tenths, check. 4 fifths is 8 tenths, yup. 5 fourths is 10 eighths, yup. They're all equivalent fractions. They're all proportions. Yes, Kyle.
So how do you know that those two sides are proportional to each other, or like that the shorter two sides or the longer two sides?
Just given these two shapes, you wouldn't know unless you were told, which I told you that they are proportional. Where we're going to be moving to is proving that shapes are proportional.
No.
Right? Proving shapes are similar.
Nice.
Okay. Yes. So if you weren't told, Kylie, then you have to prove it first before you get that. Okay. Other questions on the setting up of proportions, corresponding sides, solving of proportions? Okay. So things get a little bit trickier. When it says the two figures are similar, what two figures are we talking about here? Anthony.
There's a shorter one and then there's a longer one.
What do you mean?
Wow.
The first triangle. Well, can't I go from any? BDE.
Yeah, yeah.
And then
We have triangle BDE, right? This kind of smaller triangle that's inside this larger one. And then we have triangle BAC. Okay?
oh yeah.
And whenever you have a shape inside another one, like this, where it shares that angle, they are going to be similar. So even if I didn't tell you, right? I will get to this later on, but just so you know, whenever you have a shape inside another one, so they share one of the angles, they are going to be proportional. They're going to be similar. Okay? But we're looking for what proportions can be written, and it might help you, okay, to actually draw these two triangles out. Here's B, comes down like this, over like this, up like that. Here's D, here's E. And then if we draw the larger one, again, here's B, This one is large, it goes down like this, up like this. We got B here, we got A here, and we've got C there. Okay? Aiden, give me one.
X over 24 is equal to x minus 3 over 18.
That was a lot of things. Let me write that down. X over 24 is equal to what?
X minus 3 over 18.
X minus 3 over 18. Let's take a look at this here. Where do you get the X from? What side is X?
BA.
BA, right? We've talked about this kind of notation before. That segment kind of going all the way down, the X is between with the brackets on each end. It means that the whole thing, all of it, is X. So BA equals X. And you're comparing that to, where did the 24 come from?
It came from 18 plus 6.
Right. BC, right? From B to E is 18. E to C is 6. So because of the
Hinge theorem, yep.
segment addition postulate, you were close. CO2, CO32, you know. We know that BC is 24. Okay? So we're starting with the larger triangle here. And because we compared BA with BC, we're going to be looking to compare BD and BE now, right? Those are those corresponding sides with the large triangle. Okay, I heard we're confused, so let's just stop, right? Take a look at where X came from here. X was the entire length of BA, right?
Yeah.
So I label it there, right?
Yeah.
24 came from the entire length of BC.
Yeah.
Okay, got the 24 there. All right, so the two sides that Aiden used in this first proportion were BA and BC. The sides that correspond with BA in the smaller triangle is BD, right? And he labeled BD as X minus 3. Why? Good question. Aiden, explain why you labeled BD as X minus 3.
I noticed that DA was 3, and BD minus DA would, or BA minus DA would equal BD.
Right, again, coming back, that segment addition postulate. If BA, this entire thing is X, but BD is only, you know, it eliminates that 3, we're taking 3 away from whatever the side length is. Just throwing random numbers out there. If BA was 20, and this is 3, what would BD be?
17.
17. 20 minus 3. If BA was 50, what would BD be? 47. 50 minus 3, or X minus 3, right? So the X minus 3 came from that BD will always be 3 less than whatever X is. Because X is the entire side, BD is only a section of it. So if we know what X is, take away that 3 that's not part of BD, and that's where X minus 3 came from. Okay? And then what is the length of BE, which is the corresponding side with BC?
Sorry, which one?
18.
18.
18, right? And that's where we got the 18.
Now it's over.
Between 8.
I was trying to make I turned this one into a subtraction symbol. I missed on that. Thank you for yet again pointing out my faults.
You're welcome.
Okay. Questions on that setup there, Catherine?
I don't understand the proportions.
Which,
Like, I get, like, everything else, but, like, how it's set up, I don't understand.
okay, do you see where the X came from here
Yeah.
in the 24?
Yes.
Okay, so because we chose X and 24, notice where those values are on that larger triangle. Remember we talked about using corresponding sides? We have to, for our second proportion, use the side in the smaller triangle that corresponds with the side in the larger triangle, which is BD. You see that? Okay. You see how we got the X minus 3 for that? Right? And then the 24, right? The position of that side in our larger triangle, we have to use the side that corresponds to it in our second proportion. So BC is 24, BE is 18. That's how we got this relationship here.
Oh, yeah.
We're essentially going big triangle to small triangle. Or sorry,
Yeah.
big triangle to big triangle. X over 24, and then corresponding sides, small triangle to small triangle, X minus 3 over 18. If we wrote this in letters, maybe a little bit easier to understand.
No, it's okay. I got it.
I don't though. I'm still kind of confused. So what we did, okay? BA is to BC as BD is to BE. What's the relationship of BA and BC? BA and BC are part of the same triangle, right? They're both part of that larger triangle. What's significant about BD and BE? Well, BA corresponds to BD, right? BC corresponds to BE. That's how we know we're using those sides in those positions. Okay? Claire.
Why do we need the proportion? Why can't we just like set up an equation? You know?
We just did. A proportion is an equation.
Why do we need to have?
Because
Roasted.
because what an equation does, an equation sets a relationship, right? An equation sets a relationship. That's what we have. We use equations for our own other angle theorems that we use. The triangle sum theorem, the x-unit angle theorem, right? It tells you what the relationship is of whatever you're trying to solve, right? In this case, because they're proportional, a proportion is what sets that relationship. So we did set up an equation because we need to know what the relationship is. And that relationship is proportional because they are similar figures. Okay? Is that too many words?
Yes.
Okay. We did set up an equation, and the equation we set up is a proportion.
How do you solve it?
Cross product.
Come on,
Like
Jack.
we opened with. Okay? Yeah? Vince.
Where do Mr. Link go?
He had to go feed his dog.
He needs spawn.
So to do 24 times.
So, answering Jack's question here, how we'd solve this is we would take 18 times x, okay, and set that equal to 24 times x minus 3. And again, don't forget to add parentheses. Okay, so maybe, Claire, this is what you were more looking for here, like an actual equation, right? Here's our actual equation. And then just like we did up in that top part, we're going to have to distribute. Gives us variables on both sides. What's that?
I can't see anything.
Feel free to stand. You're in the back, so it's okay. Okay. Distribute that 24 into our parentheses. We get 24x minus 72. Move our 24x over to the other side using opposite operations. Negative 6x equals negative 72, and ultimately x would equal 12.
Perfect. Hold on, let me write all that down.
Please do, by all means.
If you can't see the board, you can use the standing desk. No one was
Could use standing desk.
Okay, we are good to go. Perfect.
Are we sure?
Yeah.
We're not pausing.
My shirt's so wet.
Okay. I would like you for tomorrow. I see you for a very short time tomorrow before your much anticipated poetry slam.
Yeah.
You told us we would have more time.
I am giving you the length of AC. No, I'm not. I want you to solve for the length of AC. We'll call this N. Okay?
That's tough.
Looks about.
Set up the proportion. None of this
Oh,
looks
I know how to
about
do it.
stuff. Set up the proportion. Okay? And solve for side N.
Okay, so
Questions, comments, concerns, complaints, comments, congratulations, criticisms. Guess what? It's time to go home. Well, not home, but next class.
please